So let's try completing the square of these two equations. Our first one is y is equal to x squared minus 20x plus 42. Now this is not a perfect square trinomial, but we can make it that way by using our equation c is equal to b over 2 squared. Well, in this case, our b is negative 20. So we'd have our c equal to negative 20 over 2 squared. Well, negative 20 over 2 is negative 10, and if we square negative 10, we get 100. So what we're going to do is we're going to take y is equal to x squared minus 20x plus 42, and we're going to add 100 to both sides. If we do that, we'll get y plus 100 is equal to x squared minus 20x plus 100 plus 42. Now, this part of our right-hand side is now a perfect square trinomial. So this will factor into an x minus 10 times an x minus 10. Because negative 10 times negative 10 will give us our 100, and negative 10 plus negative 10 will give us our negative 20. So if this is x minus 10 times x minus 10, we can also write that as x minus 10 squared. And then don't forget that we have this 42 on the outside, and the other side is still equal to y plus 100. Now if we simplify this, we'll subtract 100 from both sides, and we get y is equal to x minus 10 squared minus 58. So here is the factored form of y is equal to x squared minus 20x plus 42. Notice that this is also in vertex form. Remember, vertex form is y is equal to a times x minus h squared plus k, where your vertex is equal to hk. So now let's try our next quadratic. Here we have y is equal to x squared plus 16x minus 12. Now again, this is not a perfect square trinomial, but we can make it that way by using our equation c is equal to b over 2 squared. So if we have c, and that's equal to b over 2 squared, our b is 16, which means we have 16 over 2 squared. 16 over 2 is equal to 8, so it would be 8 squared, and that's equal to 64. So if we have y is equal to x squared plus 16x minus 12, we're going to add 64 to both sides. That'll get us y plus 64 is equal to x squared plus 16x plus 64 minus 12. And this section here is our perfect square trinomial. This will factor into an x plus 8 times an x plus 8, or x plus 8 squared. And again, don't forget there's a minus 12 out here, and this is still equal to y plus 64. So to simplify this, we'll subtract 64 from both sides, and we get y is equal to x plus 8 squared minus 76. And this is our factored form of this equation. And again, notice it's in vertex form. Now notice up until now, all of our quadratic equations that we've been completing the square on have had a quadratic coefficient or leading coefficient of 1. So can we still complete the square when we have a leading coefficient that's not 1? Well, no. So if we want to complete this square, we have to divide everything by 2 in this equation. Or if this was some other number, we would divide everything by that leading coefficient. So if we divide everything by 2, we'll get y over 2 is equal to x squared plus 16x minus 15. Well, now we can complete the square. This is not a perfect square trinomial, but if we use the equation c is equal to b over 2 squared, then our b is 16. So our c then would be equal to 16 over 2 squared. Well, 16 over 2 is equal to 8, so that's 8 squared, which is equal to 64. Which means we're going to add 64 to both sides of this equation. And if we do that, we get y over 2 plus 64 is equal to x squared plus 16x plus 64 minus 15. This here is our perfect square trinomial. If we factor that, it'll become x plus 8 times x plus 8, or x plus 8 squared. Now this is still having 15 subtracted from it, and it's equal to y over 2 plus 64. So if we have y over 2 plus 64, and that's equal to x plus 8 squared minus 15, then we'll have to subtract 64 from each side, and we'll get y over 2 is equal to x plus 8 squared minus 79, and then we'll have to multiply both sides by 2. So we'll get y is equal to 2 times x plus 8 squared minus 158. So here is the factored form of y is equal to 2x squared plus 32x minus 30. Now our last example is y is equal to 2x squared plus 1x minus 2. And again, we have a leading coefficient that is not 1. So we're going to have to divide everything by this leading coefficient, or divide it all by 2. If we do that, we get y over 2 is equal to x squared plus 1/2 x minus 1. Now again, this is not a perfect square trinomial. So we're going to have to find our perfect square trinomial. We use c is equal to b over 2 squared, where our b is 1/2. So if we have 1/2, divide by 2 and square it, that should get us our c. Well, 1/2 divided by 2 is equal to 1/4, and 1/4 squared is equal to 1/16. So we're going to have to add 1/16 to both sides. And if we do that, we get y over 2 plus 1/16 is equal to x squared plus 1/2 x plus 1/16 minus 1. This here is our perfect square trinomial. This will factor into an x plus 1/4 times an x plus 1/4, or x plus 1/4 squared. And again, we subtract 1, and this is still equal to y over 2 plus 1/16. So if we have y over 2 plus 1/16 is equal to x plus 1/4 squared minus 1, and we would subtract 1/16 from both sides. That would get us y over 2 is equal to x plus 1/4 squared minus 17/16. Because this 1 here, that's equal to 16/16. So if we have a negative 16/16 and we subtract another 16th, we'll end up with 17/16. Now our last step would be to multiply by 2 on both sides. So what we get is y is equal to 2 times x plus 1/4 squared minus 34/16. So here is factored form of y is equal to 2x squared plus 1x minus 2. And that completes our tutorial on completing the square.